Now I want to create the slabs for the front and the ends. I'm going to go ahead and hide the two slabs that I've created already. And next step is to go in and sight down the direction you want to create your slab in, which is going to be down the Y. And before I create that new slab, I need to right mouse click on the compass, and I want to take my privilege plane and make it my ZX plane. Once that is set, I can now draw in the planar patch that I need for that front. Next thing I'm going to do is change my distance analysis again. Just double click on that. My surface is this. My target is this, the front. Select OK and proceed to fit to geometry. I want to fit this to this target. I have a really good deviation, less than 1/4 of a mil, and select OK. Now I want to do the ends. So once again, I want to sight down, click on my X, right mouse click. This is my YZ plane, and draw in my planar patch. Since I'm going to use two of these, I'm going to take this and I'm going to Control C on the keyboard for copy and Control V on the keyboard to paste. So now I have those two. Once again, I'm going to modify my distance analysis. Double click on that. Surface number 5. And for my target, I'm going to use, I could use either one. Let's go to this end, forward end, and select OK. Fit to geometry. Three by 3, everything looks really good. I'm going to double click on my distance analysis. Once again, change it to the new surface, to the new scan on the aft end, and fit to geometry one more time. Zoom in, take a look. And once again, everything's really close, looks fabulous, and select OK. And there we have all of our primary slabs. Let me go ahead and show these so we can see our good work. Now that I have my initial primary slabs, I need to increase their size. As you can see, they don't quite match to the size of the initial scan. So I have to make them all bigger. And to do that, I'm going to use my Extend tool. But before I turn on the Extend tool, I'm going to turn on some of the control point displays for these. I just want to get an idea of what's going on with the at least larger surfaces. So I'll just pick these 3. Display, control points, select OK. Now, let me just go ahead and hide this distance analysis. I'm going to go in and double click on my Extend, because I'm going to use it a few times. Pick my first surface and extend it out. I want to be about 10% larger than the final part that I'm working on. Something a little bit bigger, because it's always easier to build it bigger and trim it back. So in this case, my primary slabs across the top is a bit larger. And as I analyze it, I can see what's going on with the control points. You can see back here, there may be something going on. This may be a styling requirement. But it's a good way to visualize exactly what's going on with the shape of that surface. Select OK. I'm going to do the same thing with the front. Enlarge that. Bring this up. And drag this down. There we go. Again, making sure that it completely encompasses that part. If I don't, I can always go back and extend it again. And just work my way around the part. You can see as I'm pulling things, the control points recompile themselves in order to maintain the initial position of that first surface. So there's no deviation really that's going to happen back to the mesh as measured. So we'll take this end cap, drag this out again, bring this back, and we can see that we have that fully encompassed, and do the same thing with this end cap. And just like that, all of my primary slabs have been increased in size. Everything still looks pretty good, and I'm going to turn off those displays. Now that we have our primary surfaces set up, the next step is to create our secondary surfaces. So we're going to take a look at the mesh and figure out the next logical step is going to be these blends on either end, the large blends. These bottom blends that wrap around are going to be constructed afterward. So we need these secondaries here in order to build these additional blends across the top and the bottom. So to frame these out, I'll sight down the y-axis. We click again to look at the other side. And I'm going to right mouse click on the compass. And I want to make my privileged plane, as you can see, the ZX. Now that it's set to ZX, I'm going to draw in a couple of 3D curves, but I want those curves to go into this curves geometrical set. So I'll right mouse click here, define and work object, double click on my 3D curve, and I'm just going to pick a couple of spots above and below and just eyeball where this curve is going to go. Just like that. Close enough. You can always go back and make modifications later. I'll do the same thing on the other side and create that curve. Select OK and cancel. Next thing I want to do is generate these edges with curves once again. And to do that, I'm going to go into the generative shape design. I'm going to do a couple of intersections. I'm going to intersect this front with this end and do the same thing, this end and the front once again. Cancel out. And then I'm just going to simply take those intersections and parallel them to the location that I need. So I'll take this curve on that surface, reverse the direction, and drag it out. Get it to the spot that I need it at. That looks close enough, and select OK. Do the same thing on the opposite end. That curve, that surface, drag this out. We turn this so I'm looking at it from the inside. And as you can see in this case, it's a little different in shape. So I'm going to use a slightly different parallel curve definition. I'll just go to law, say linear. I'll just shoot this out to 25 for now. And preview. So for this, I'll come down here, go to 20, and take this out to 35. Take a look at, see what we have. Pretty close. I need to bring this out a little bit more. We'll go to 45, preview, and as you can see, I can work my way up into getting that curve right where I need that curve to be. And to finalize the curves, these two that I've drawn out in space, I'm just going to use project. I want to project this curve onto this surface. The direction that I want to use, I'm going to right mouse click. And if I look at my compass, you can see that it's along the Y, current, preview, and there's that curve. I'll do the same thing. Right mouse click, Y component current, and select OK. Cancel that out. Now that I have my curves framed in, I can put in my blend surfaces. Now that I have my curve frame in, I'm going to go ahead and create my secondary surfaces, the actual surfaces through those curves. And for that, I'm going to go into Blends, right mouse click, define in work object, and use the blend operator here in generative shape design. I'm going to go from this tangency to this surface, this tangency to this surface, and I want to make sure this says curvature. Hit preview, and there is my initial blend. If it doesn't quite match up to the scan, you can go into tensions and increase the tension a little bit or decrease the tension a little bit. And what this is going to do is it's going to give it a little bit more crown to the surface. And preview, select OK, and do the same thing on the other end. Here's my curve, surface, curve, surface. Go to tensions, everything's still the same. Preview, looks pretty good, and hit OK. At this point, I'm just going to do a quick distance analysis. So I'll go down to my distance analysis at the bottom of the tree. I'd show that. I'm going to double click on it. And my source is this surface. My target is this mesh. And as you can see, it's deviating kind of far. So with that, I'll double click on that blend, go back into my tensions, and I can begin modifying those, preview, to get this closer to the shape that I need. And as you can see, I'm getting pretty close to that scan just by modifying these tensions. I'm less than half of a mil, select OK, and do the same thing for the opposite end. I'll just double click on my distance analysis. Source is this blend, target is the mesh. This one's much closer, so just double click on it, go back into my tension, and decrease that tension, preview, and again, we're below half a mil, so everything looks good. We'll leave it alone, select OK, and we'll call our secondary surfaces done. Now I want to go through and create the top and bottom blends. First, the top blend. This can be created using a tool called Styling Fillet. And to do that, I'm going to clean up the screen a little bit. I'm just going to go ahead and hide all of the meshes that I don't need. And we'll also clean up the curves. So we're going to frame in the initial blends using that Styling Fillet tool. I'll go ahead and double click on it and pick my end cap to that top surface. Let me reverse the direction. And I want to make sure that variable is turned off. I want to make sure G2 is selected. I want to make sure that the arrows are pointing in. And I want to have a chordal fillet going through that. And I can begin typing in some numbers here and see if that matches up. 20 is a little large. Let me go down a little bit. Let me try 10, a little small, and we'll go up to 15 and see what that looks like. So it looks like it matches up pretty good. Other thing I want to make sure I don't have turned on is I do not want to trim these surfaces. So I'm going to leave the trim supports turned off. Select OK to create that blend. I'll do the same thing on the opposite side. Surface 1, reverse. Surface 2, reverse. And put in a value. This is obviously going to be a little bigger. 40 is a little large. I'll back down a little bit. We'll go down to 35 and work my way into that fillet once again. Everything looks good. The final fillet is this one on the outside here, and this tapers as it runs towards the rear of the vehicle. So I'll pick my main slab, reverse, main slab, reverse, and this time I do want to turn on variable radius. At this end, I know I had a 35mm radius capping this off. At this end, I know I had a 15mm radius capping it off. So I'll just double click on this end, enter in my 15, and apply, and see what we have. And we have our see-through peekaboo of the mesh. We can see that it lines up pretty good. I like it, so I'm going to keep it. Select OK and cancel. And as you can see, I have my 3 styling fillets set and ready to go. With my top corner blends in place, I can begin framing in the necessary geometry for my tertiary surfaces, these little ball corners that are going to go in this corner and in this corner. And for that, I'm going to go back and use some of my original references that I used to create these vertical blends. I'll go ahead and show these 2 3D curves. I'm also going to show the parallels and show those. Once I have those shown, I can begin creating that additional geometry. And for that, I'm going to start out with a projection. Let me go ahead and make my curves geometrical set my work object. I'm going to project, once again, this 3D curve onto this surface. What's my direction? Again, if I look at my compass, it's going to be in the Y. Right mouse click, Y component. Do the same thing with this curve. And that gives me my initial tertiary tangent curve. Next, I need to do these curves on these ends. And to do that, I'm going to start out with intersect. Double click on my intersect. I'm going to intersect the edge of this fillet with this curve. And I'm going to do the same thing on the opposite end. The edge of this fillet with this parallel curve. Now that I have those points, I'm going to project those points to this upper edge. So we'll just go into project, double click on that. Change this from along a direction to normal. This point to this edge. Do the same thing here. This point to this edge. Oops, I picked the actual fillet. I just want the edge. There we go. Now that I have those points in place, I'm just going to create a couple of lines from point to point. Point 1, point 2, and they're going to sit right on that surface. I'll do the same thing this side. Point 1 to point 2, sit right on that surface. Select OK, cancel. Now, I need to frame out these curves. And for that, I'm going to use the GSD spline. Just double click on that. And for this, we're going to pick this point. Tangency is this edge. To this point, tangency is this edge. Geometry on support, this surface, that corner blend. Do the same thing up here. Point, tangency, point, tangency. Now you can see that I just got to reverse those tangencies. Geometry on support. And just like that, you can start seeing what those corner surfaces are going to look like. Oops, I picked that edge accidentally. I want to make sure I get that point. There we go. Geometry on support. And one more. I'll just reverse that from now. Reverse that. Geometry on support. And select OK. And with that, I have both of those tertiary corners framed in. With my tertiary curves in place, I can begin creating the mesh surfaces that are required to make those tertiary corners. Before I do that, I'm going to clean up the screen a little bit. I'm going to go ahead and hide these surfaces that I don't need. I am going to need this top one. I'll go ahead and even hide this mesh here. And get rid of these curves. Get rid of these parallels. And with that, I'm going to use a tool called multi-section surface. Multi-section surface allows me to pick section 1. Styling fillet is the tangency or support. Section 2, support. Reverse the direction. I want to make sure these are pointing in the same direction. We'll go down into guides, support, curve, support, and select OK. That creates that surface in that corner. I'll do the same thing on the opposite side. Support, curve, support, reverse, guide, curve, and select OK to create that surface. Now that I have those surfaces in, I can take a look to see how everything matches up, see if everything is acceptable. You can see that this is pulling away a little bit here from that tangency, so I'll just double click on that spline. And with that spline, I'm just going to go in and show parameters. And I can start changing the shape of that spline using these inputs. And as you can see, that surface updates. If I need to increase the tension for that spline as well to get it closer to that edge, I can increase that tension. So now it follows more closely to that initial mesh. Once I have what I like, I select OK and do a quick visual to make sure everything lines up just the way that I want. And it sure does. Everything's looking great. Now that I have all of the surfaces that I need to make the armrest overbuilt and slabbed out, including the top secondaries and tertiaries, I'm going to go ahead and show all of those surfaces so I can begin splitting the portions of the surfaces away that I don't need. I'll show those. I will also show these curves. And now I can begin removing the material that I don't need. Let me go ahead and hide these upper blends as well. I'll come down to my splits geometrical set, right mouse click, define an orc object. And for this, we'll use GSD split. And I'm going to pick this surface first, pick this curve, that project, pick this edge off of my styling blend, styling fillet, and pick this curve at the far end. I'm going to leave it overbuilt on the bottom. We're going to come back and show you a neat little trick to finish off this bottom. Next, I'll take this corner blend, trim to that curve, this end, this curve, and this edge. Come back to this side. And this blend. I accidentally picked the surface, so let me go ahead and remove that and pick the actual curve. There we go. Pick the surface, pick this curve. Little tip is when you're splitting things, it's kind of hard to see sometimes what's being split if you don't change colors. So that's why I have that extra geometrical set in here with the graphics change. So as you are doing your splits, it automatically just changes those colors so you can really graphically see what's happening. And you'll know what's split and what isn't split. These tertiary corners do not need to be split because they were built to that mesh which fully encapsulated them. The last split I need is this top split. I'll pick this edge, this curve. Do it in that order as well. We'll pick this edge, and this curve. Select OK. And just like that, we have all of our secondaries and primary surfaces split and ready to be joined. Now that I have all of my surfaces split apart the way that I need to get them trimmed away, I'm going to go ahead and join everything together. But before I do that, I'm going to go and hide all of the unnecessary elements like those curves. We'll just right mouse click over this. Curves object, hide components. We'll go up to form, make sure that is my work object, and now go into join. I'm going to pick this top surface, and I'm going to right mouse click on top of that, come all the way to the bottom, and say angular propagation. This sort of does a check to make sure that everything is at least minimally tangent. I'm going to preview, and I'm going to check this out, make sure that everything looks good. So the quick visual is everything checks out nicely. And just like that, the complete upper portion of my armrest is nearly complete. One of the last things that we need to do is put the final blend on the bottom, or the fillet. Now, because of the shape of the fillet, let me turn that on. You can see it's basically a constant size, wraps all the way around. And for something like that, where it's at the very end and you're just breaking a corner, you can use the styling fillet on that final joined element with this bottom surface. Make sure it's G2. You want a chordal fillet with a 13 millimeter length. In this case, you want to turn on the trim support and trim support. That way it'll trim everything up and make one big final surface. And as you can see, it's really close. Everything lines up nicely. Let me go ahead and hide my lower blend. Next thing I want to do is show this trim surface. This is my door trim surface. This is going to come from somebody. This is the interface that the armrest is going to rest on. And oftentimes you have to trim everything up back to that interface. And for that, I'm going to go in and do a split on this final element to this surface. Now you can see I get this little gap. Okay, this little gap is indicating that I have a very small area that didn't quite make it out to this surface. So normally I would OK and then do the edit, but just to show you how I can get rid of that gap, I'm just going to close this, cancel, go back into freestyle, and these are my initial slabs. So if I go back to my initial slabs, slab number 3, go into extend, pick that extend. Now note, as I make this a little bit bigger, you'll see all of the blends and everything else updates right along with it. Select OK, go ahead and hide this. So I went back to that original element. Even though that original element doesn't have history, everything built from it does have history. So those things are going to update. I'll go back into generative shape design and try my split one more time. Pick the armrest, pick that surface. This time I don't get the error message. There's no tiny little gaps. I select OK. Let me go ahead and hide this. And there we have our completed armrest. Now that I have my armrest complete, I'm going to go in and do some visual checks and some distance checks to make sure everything is within tolerance and it looks good. And for that, I'm going to go back into the Freestyle workbench. First is Connect Checker. I want to make sure that everything works to within 0.005 millimeters, so basically 5 microns. I'll pick my surface, make sure G0 is selected, and you'll notice that there are no discrepancies. For G1, again, 0.2 of a degree, no discrepancies. Everything looks good. So this is within tolerance for G0 and G1. I don't expect it to be within G2 tolerance. Some of them will be, and some of the areas won't be. But again, this is an interior part. Most likely it's going to have some sort of a grain. It's going to be covered in foam. So if it's out of tolerance for G2, for perfect G2, chances are it's going to be more than acceptable. Like in this case, it's just a 5%, 4%, 2%. So that's well within any range. So if I take this up to something like 10%, in most cases, something like that is going to be an acceptable amount of deviation within the G2 realm for a component like this. Now, if this were an exterior part, something that has high reflections, surfaces that are big, broad, and flat, that are going to reflect a lot, then you want to make sure that G2, even G3 continuities are well within the spec that you've been given. But again, since this is an interior part, it's going to have grain on it. It's going to be made out of foam. G2 in these little areas like this isn't truly necessary. You can go back and correct it if it is, but for the most part, in most places, most studios, that's not going to be an issue. Let me go ahead and hide that. And the next thing I want to do is a highlight lines analysis. Select my surface, say normal. We'll go down to 3 degree. And with that, just zoom in and take a look and verify how everything looks. If you see any areas that are cause for concern, you can go back in and make modifications to your base geometry to fix those things. So as we go through, we can verify that everything looks really good. I'm going to right mouse click on my compass, change my privilege plane, and run the check one more time. Again, everything looks good. There's no sudden changes or breaks. Everything looks pretty good. And try it again in the third direction. Now remember, generally speaking, for something like this, only 2 directions are necessary to make sure that everything looks really good or nearly perfect. You're never really going to get all 3 directions to look perfect. It's just not going to happen. It's just not the case. So for something like this, check it out in 2 of the directions. If something's a little weird in the third direction, that's perfectly fine. It's an acceptable condition because the other 2 reflect line directions look just fine. This looks great. Select OK, and just like that, we have a nice visual check, and the armrest looks great. Now that we've built ourselves a parametric armrest using tools in Freestyle and Generative Shape Design, we're going to go through and exercise the part a little bit, make some modifications to show you exactly what happens to the part, how well it can exercise, and with the reflect lines showing, you can see what the shape is doing as well. So for the first thing I'm going to do is I'm just going to go ahead and turn off my edges. So I'll come down here, turn shading off with edges. So all we're looking at is the actual final shape and the highlight lines. Next, I'm going to go into the styling fillet, change this from 35, we'll go up to 40. And once I do that, you'll see that fillet changes, the highlight lines update, everything flows nicely. If I do the same thing up front with this styling fillet, we'll go down to 10. You can see everything updates nice and clean. Other modifications that I can perform on this as well is I'll go into the curves and I'll show one of my 3D curves. So I'm going to sight down my y-axis. I'm going to right mouse click on my compass and I'm going to change this to the XZ for my privilege plane. So that way when I move my control points, they stay on plane. Now as I move this, you can see that dynamically those highlight lines are moving and the part is updating. So we can now go back, make changes really quickly, update the part, visualize what's happening, make sure everything is looking good as those changes are happening. And just like that, we have a part that's morphable, updatable, viewable, and something that you can use again and again and again, maybe as a template to set up an additional armrest. You can add pockets to it and so on and so forth. But these base elements, they're very stable, and as you can see, they update cleanly. And that's it. Thank you for joining me in your Class A surfacing journey. If you'd like to learn more, please check out my other courses in the LinkedIn library, or please feel free to browse my YouTube Class A surfacing channel. Thank you. When people ask me what Class A surfacing is, I often tell them it's art and engineering coming together. To go a little deeper, a stylist lays out some ideas, and the digital modeler takes those ideas and makes them a reality, a digital reality, through Class A surfacing tools and techniques. In this course, I'll show you the standard tools and methods used to create a Class A quality part. From slabs to secondaries and your tertiary surfaces, all the way to analyzing what you just created to confirm that your final part meets its engineering and styling intent. I'm Stephen Margia, CEO of Class A Surfacing. Join me and let's make some shapes. This course assumes you have a working knowledge of Catia. If you need a refresher, please check out my other courses in the LinkedIn library, Learning Catia V5 and Catia V5 Surfacing. Also, we will be using NURBS elements within this course, non-rational B-spline surfaces and curves. We won't be getting too much into the math of things, but we'll be showing you how to manipulate these elements within the software. What is a Class A surface? It's basically everything that you see and touch or engage with inside of a car, outside of a car, inside of your home, whether it's furniture or on an airplane. Something that's been stylized to meet a certain requirement. Maybe you want a car to look like it's going fast while it's sitting still. Maybe you want something to look big and strong and bulky, or something soft and a little bit more tender to the world. It's the emotional connection that the stylist has that is brought to the real world by a digital sculptor. The digital sculptor takes these inputs from the stylist and creates these surfaces to meet the requirements not only of the stylist, but also for engineering and manufacturing purposes. It is the connection of art to the real world. Something that most people are unaware of is the actual beginnings of where Class A surfacing came from. The terminology, the tools, the verbiage, they all have a nautical base. Hundreds, if not thousands of years ago, ships and boats were built using long slats of wood called splines. Those splines were wrapped around control points. There are also other aspects of where splines were joined together at endpoints called knots, and so on and so forth. So if you really want to get a good, deep understanding of where these terminologies come from, go research shipbuilding. It's a very interesting topic, and it'll give you a really good, strong foundation of where all of this comes from. Now, to relate that into a CAD system, what you see here is a surface. That surface has control points. These control points control the actual shape of that surface. This surface also happens to have an internal knot point, the solid blue line that runs through that. To the eye, you won't see that. This is something that is visualized using an analysis tool just to show you here in this example. That knot point is technically two surface patches that come together, and internally they determine that it is one giant surface across that knot point. Again, that would be representative of two planks coming together end to end or side to side. These control vertices or hulls or control points, depending upon what system you're using, as they're called or referenced, are again controlling the shape of that surface. For a surface that requires a lot of shape, you're going to require more of these control vertices as well as these internal patches. The more shape that something has, the more control it requires, the higher the math. So you're going to need a lot more of these control points. Another example, let me hide this and show this. You'll see that I have this surface attached to this surface. These are wholly two independent surfaces that have been joined together across a boundary. This is a splitting or a facing tool that trimmed back that surface and joined those two surfaces together. So this patch is a separate entity than this patch. They just happen to be joined as a singular surface in this case. This is an external boundary. You'll hear these terms used interchangeably through the course: patches, edges, boundaries, control points, control vertices, hulls. So those are the most basic terms that you need to understand when creating a NURBS element for a Class A surface. When you're designing your Class A surfaces, there are three things you have to consider: your primaries, your secondaries, and your tertiaries. Your primary slabs are your biggest, most general shapes. They basically capture most of the intent. Your secondaries, these blue surfaces here, are typically your blends between primary surfaces. These primary surfaces have a nice general flow capturing the largest slabs, overbuilt geometry. So easier to overbuild and come back and trim things up as necessary. So to connect these primary slabs, we put these secondary surfaces in, and oftentimes where secondaries and other primaries come together to form these little almost ball corners, they're called tertiary surfaces. These are typically the most mathematically complex because they are built off of blend surfaces, which they themselves are relatively complex. For every order of continuity that you require out of a surface, you have additional math that needs to be imparted on that surface. And coming off of your primary surfaces, which even though they're the biggest shapes, they should be the simplest mathematical representations of shape in your part. We want to try to minimize the amount of math in these. And the reason is because every downstream function is going to increase the complexity of said surfaces. So the next surface built off of it's going to be a little more complex, and so on and so forth, until we get into our tertiary surfaces. And as you can see here, generally speaking, our tertiary surfaces, these little ball corners, are the last things that we build. These are the things that are just taking, in this case, a tight little corner, wrapping it around these big, gentle blends, and just finishing off those surfaces. So when you're laying out these patches, when you're laying out your design, you want to try to encapsulate as much of that design with your primaries, and then think about where your tangencies are going to go to bridge across those primaries with your initial secondaries, and then to close everything off with that final tertiary surface. I'm going to be talking about continuities, and I'm going to use curves to show you what a continuity is between adjacent elements. And this is the same for surfaces. It's just easier to show using curves. I'm also going to use a tool called porcupines to really show you exactly what's happening with those continuities. So we'll be talking about these tools later on in the course, but I'm just going to use them here to show you what continuity means. If I look at this end where these two curves come together, you can see that I have a quill and another quill that are parallel. At this endpoint, I'm showing a tangent condition, meaning that the slope vector at the endpoint of this curve and the slope vector at the endpoint of this curve align. So I have a smooth condition, or G1. If I go to the other end, I have what's called a G0 condition. And this is obvious because the quills do not line up. They're not parallel. And because of that, the positional continuity is held, meaning G0 is held at those two endpoints, but it's a hard corner. So anytime you see something like this, it means you have a hard corner. The other end is tangent, meaning it's smooth, but because it's just a simple tangent condition, it's something that may not be pleasing to the eye or aesthetic when creating a Class A surface. especially if it's something really shiny. This is something you really see. I'm going to double click on the spline, and you'll notice that for this point, it's set to tangent. I'm going to change this to say curvature, and you'll note that as soon as I go to curvature, this is what's called a G2 condition. Across that point, there's a radius from the first curve. And across that point, this second curve now shares that same radius. It means, in this case, that the two endpoints are G0, they touch. They are tangent, meaning they have the same slope across that point, and they share the same radius across that point from one curve to the next, meaning that it's smooth. So this is going to give you an aesthetically pleasing condition across the boundary between these two curves. And the same, again, is held true for surfaces. When you're doing surfaces on an exterior body panel, you may need to do things like accelerate that curvature. As you can see here, I'm accelerating it because I want even a smoother transition across that boundary, going into what's called G3. That G3 is the rate of curvature plus acceleration. So everything that you see on an exterior body panel with large flowing surfaces is going to have a G3 condition. When we're talking about tighter areas, small areas, maybe things in the interior, then G2 is acceptable if it's going to be something with a grain, maybe something that has not quite as bright or shiny a finish or wrapped in foam. G1, maybe with some acceleration like a conic or something along those lines, would also be acceptable. Again, if it's a small blend or a small fillet or tiny little areas and it's an interior, a lot of times a G1 condition is just fine. And again, you can get away with using a conic. Even though it may not be perfectly G2, it sort of fakes the G2 condition. So as you're designing things, it's very important to always consider what's happening to the shape of that curve and that continuity. So once again, I broke that curvature. I brought it back down to tangency. These are parallel at the opposite end. This is G0. This is simply touching. And once again, if I come in here and impose that tangency and impose that curvature, you can really see that shape change across that boundary. So a very important aspect of Class A surfacing is making sure you have the right boundary conditions, the right continuities across those boundaries of your primaries going into your secondaries, going into your tertiaries. Before we get into designing anything, we want to make sure that our options are set correctly. And for that, we're going to go into Tools, Options. Under Shape, we have a tab called Freestyle. Freestyle allows us to control all of the options within the Freestyle workbench. You can set up your tolerances, set up your auto detection, what you see, and the attenuation for tuning, as well as what you're selecting, and so on. You also have a tab for manipulators. If you want to change what your manipulators look like, you can come in here and select what you want the center points to look like, the crosses, the color of the manipulators, as well as the various mesh properties. So as you can see, it's extremely customizable to your preferences. Now I want to talk about some common tools. These are tools that you're going to use in quite a bit of the functions within the Freestyle workbench. These are located in the Tools dashboard, which I just pulled out. When I enter into one of the functions, like this surface, and in this example, use control points, you'll notice that several of the tools on the Tools dashboard become active. These allow you to visualize, as you can see, the continuities. You can also turn on and off the orders as well, and control the attenuation, which is the amount of movement that happens as you move the mouse through space. So as you're going through and working within the context of Freestyle, you need to make sure you pay attention to this dashboard. As an example, right now my attenuation is set to high. If I grab this control point and I move it, it doesn't look like anything's going on. Now, if I change this and say no attenuation and grab that control point, you'll see that the control point is actually moving. So the high attenuation is just allowing you to make very precise small movements, whereas no attenuation is just move as the mouse moves. So again, these are common tools on the tools dashboard. You can also control your compass. You can control the step mode and the dynamic motions. And depending upon what function you're in, you'll also have a figurative displays and variants. So just pay attention to this dashboard as you're working along. What you're looking for may be located here versus within the actual menu itself. In Catia, there are two different types of splines we need to talk about. First is the Generative Shape Design, or GSD spline, which you should already be familiar with. Next is the 3D curve. This is a NURBS type of spline. And there's a couple of creation types we're going to discuss. There's the through points and control points. And with these, if you're not picking any sort of background data, everything that you do select is going to default to what's called a privileged plane. So if I look at my compass and I right mouse click on this, you'll notice that I have a privileged plane for the XY. So this means if I start picking out in space, you'll see those points default to that XY plane. Again, if I pick a point that's off plane or an edge or something like that, then it'll snap to that point. I'm going to cancel. I'm going to right mouse click, change my privilege plane. Now notice the orientation of the compass has changed. I'm now looking at my YZ plane as my privilege plane. And with that, when I go into my 3D curve, you'll notice that the points that I select now default to that plane. These are the actual through points that this spline is running through. If I move this, you'll see the spline changes shape. If I need to add additional points, by default, the next point is going to be added after the last point that I dropped. So if I pick a point out here, you'll notice it goes to the next. Or if I need to insert a point somewhere in between, I can come in here and say insert, pick the segment, and then specify the location. This allows me to add more shape and complexity to that curve. If I need to remove a point, I can right mouse click on it. I can remove this point, or I can come over here and specify remove a point, select the point that I want to get rid of, and it's gone. The next curve type is called control points. So for this curve, when I switch the type, you'll notice that those points become those control vertices, and between those vertices are those hulls. These determine the shape of that curve, but not as the curve passes through those points. So these are the slopes determined at each one of those locations, and the curve is driven by these locations in those shapes. And it operates in the same fashion as the through points, as far as being able to insert an additional control point and the movement of, as well as the removal. Other options that you have in the menu are to disable geometry detection. So if I'm drawing something and I have background data that I don't want to accidentally select, I can turn this on and no data will be selected. Another option I have is hide the pre-visualization curve. If I turn this off, it's going to show that curve, and what this will do is it'll show me what that curve would look like if I select the next point. For this course, I'd like to turn that off and visualize the curve as it is. Now I want to talk about project, intersect, and combine. And for that, I need to go into generative projection type. We have normal or along a direction. For this, I'm just going to pick the curve and hit preview. You can see it projects the curve up on a direction. And now I need to specify which direction. And that's my curve. I can also do similar to a project in that it's working with a curve, but in this case, it's working with two curves. So we'll pick these two, and it's going to from planar curves. If I have non-planar curves, or if I want to project along a vector direction, I can specify along directions, and then here I can specify my direction. Parallel curve is used to take a curve. Curve does not assume a support. Here, and then I can specify that distance. Specify the type of distance that I want with a law. I'm going to use a linear. We'll go from 92 to 50 and move this end all by itself. Now I want to talk about extrude and revolve. In generative shape design, we have extrude and revolve. The revolve works basically the same as it does in the freestyle. Click on revolve, specify your profile, specify your revolution axis, and then determine your generative shape design. Allows you to specify a profile. In this case, it's a planar curve, so it has a normal. If I want to, I can specify and determine your limits. You'll notice in the tree, it calls it out as an extrude 1. Go ahead and hide that. Now I'm going to switch to the freestyle workbench. And within the freestyle workbench, I have that revolve tool. Again, this is basically the same as it is in generative shape. The difference is the extrude tool. With extrude surface, you'll see that this looks a bit different. The surface is no longer called an extrude, it's just simply a NURBS surface. So the big differences here are the end result. The end result in the as well as 4-point patch. The first one, planar patch, allows me to pick 2 diagonal points. Now you'll notice I pick the first point, and at this moment I can right mouse click and say edit orders. This allows me to control. It's not a big problem or anything like that. I'll just hit close, point. Once again, under the planar patch tool, I go to 3-point patch. And for this, you pick 2 diagonal points. And the third point is allowing you to determine the size of that and change the complexity of that surface again. Select my point to finish that off. Notice these are all going to the XY plane. And once again, that's because of my privilege plane. If I want to space, or in this case, corners or vertices off of adjacent surfaces that you want to use. And this allows you to pick 4 points, and no, they do not have to be planar. And then once I pick that 4th point, the surface gets generated. Again, none of these are history-based. As you can see, they're all NURBS-based surfaces. There are 2 types of blend surfaces that I want to talk about. One of them is in generative shape design. In this case, I'm just going to pick this edge and select this support, pick this edge and select this support, and preview. Off of these corners. Change this to none and preview. You can see the shape has changed here. You cannot control the complexity of the surface. The surface is derived, and it retains that blend. And as you can see, it is a parametric surface. Let me go ahead and hide that. I'm going to go back into Freestyle. And in the Freestyle, we have the Freestyle blend surface. And with this, I pick near the edge that I want. Once again, edge, you can see an indication of which edge is going to be selected. And it creates curvature continuity. And once I create this surface, I'm going to select OK. You'll notice that it creates a NURBS surface. So there's no history on that surface, but I can now use this surface using the Control Polygon tool. Because it's a multi-section surface, it also allows us to add guides. So this is a mesh surface. Window, and select the three dots and pick guide curve 1 and guide curve 2. If I have adjacent surfaces for tangencies, I can pick those as well. I select OK, and using one of the boundary curves. So here I can say I want this to be curvature, and you'll notice the surface updates right along with that curve. I can increase the tensions as well. So if I have additional splines, maybe 3D curves, GSD splines, whatever they may be, or adjacent surfaces, I can pick on the interior of the surface in both the section and the guide directions. To be quite frank, you could pick dozens and dozens of curves in the section and in the guide directions as well. But I don't recommend you going to objects and allow the system to do what it's going to do to create that shape or the transition. It does a fantastic job in allowing you to create very smooth. Next, I want to talk about fit to geometry and control points. What fit to geometry allows me to do is pick a surface and some targets. In this case, it's a mesh. This mesh is off of a clay scan. Somebody modeled up a clay part, scanned it in, and brought it in. Because the scan has tool marks, it could be a little rough, we're going to surface over the top of that scan. That scan is our reference to design up to. So we're going to take that surface and project it up to that scan. Once I have those objects selected, these targets could also be curves. It doesn't have to be a scan. I'm going to say fit, and as you can see, it takes that surface and pushes it up to that scan. You're going to see some variations in distance and deviations off of the original scan, which is what you want. There may be a tolerance involved, maybe 1/4 of a mil, 1/2 a mil, an entire millimeter, or more, depending on the quality of the scan, as well as how tight you need to hold to that scan. And with that, I have the ability to increase or decrease the amount of math, the NURBS math, by right mouse clicking on one of those little flags, and then reimposing the surface onto that mesh. If I just simply click on that number, you can see it just goes up and refit it. So I may be getting closer, pushing it further away, creating undulating surfaces. So it's kind of a dance between what you want to do and what the system wants to do. So you have to find that nice medium, someplace where the surface is very simple as it can be, but really close to the mesh without absorbing any of the flaws of the mesh. Once I get it close to what I want, I select OK, and you'll note that there's no history here. And then I can go into control points. With the control points, I specify my surface. The support here is the direction in which I can move those control points. More often than not, you're going to use something like local normals along mesh lines or normal to compass. So there are plenty of other ways to move these around, but for the most part, generally speaking, normal to compass, mesh lines, and local normals. In this case, if I say mesh lines And what do I want to move? One of the control vertices or the entire hull or the mesh? Now when I pick on that mesh, you can see it's the entire row, not just one of those points. And I'm causing a swing and deviation back to the original mesh. If I want to move just one of those points, I can pick point right over here, pick the point that I want, and as you can see, I'm moving just a singular point. I can do the same thing up here, and I'm moving just that singular point. I also have the ability to go local normals, and with this, single point is specified, so only the one point will move. If I want to move the entire row, I come back in, specify mesh only. Now it's the entire row. If I pick this row here, you can see it highlights it orange, and now I'm able to move that entire row. This is just a combination of points and mesh, so you don't have to toggle back and forth. If I want to move along a compass direction, the compass direction is the Z of the compass. So you're going to have to, again, right mouse click and change the orientation of said compass, or drag it and drop it and put it onto something that defines the direction you want to move. Again, it's the Z direction of the compass that the mesh will move in. So now if I grab the mesh, it'll move in the Z direction. If I have a bumpy mesh, or I've done something and I want to smooth the mesh out and let the system do the work for me, I can come in here and do something called harmonize. And what this will do is it'll harmonize those control points, sort of smooth everything out a little bit and take you back to more of a neutral or cleaned up mesh. And then I can go back in and begin manipulating those control points as I see fit. So if I wanted to move, again, local normals, and start moving those around. So again, this allows you to tweak or manipulate that surface to get it to the shape that you need. As soon as I do that, it moves that edge to the adjacent surface. Here you can see it's making it curvature continuous. Now, also at the same time, I have this little information that pops up. It says your surface is over constrained. The reason why it's over across that boundary. If I came in and said project endpoints, it remembers where those endpoints were from the initial surface, and it just projects them over to that adjacent surface. So it doesn't necessarily mean it has to run across the entire boundary. And with that, I can now do some adjusting of that across that edge as well. I can just remove that and it'll take it all the way to those endpoints. Even if that's not, and now my surface is G2 or perfectly smooth across those boundaries. Select OK. And again, note, there's no history to this tool. So if I were to make additional modifications to this surface or this surface, I would have to go back there and do the match once again. Now I want to talk about the freestyle offset. With the freestyle offset, I have simple and variable. With simple, you select the surface you want to offset. It offsets at the distance. You have some control over tolerance. If you want to, you can control based off of the order as well. We'll just leave it at tolerance and select OK. Now notice that if I leave everything as is, it moves the surface. I'm just going to hit Control Z on the keyboard and undo that. If I do offset once again, and I want to do an offset of that surface without moving the surface, there is an option here that says Keep Original on my dashboard. I'm going to turn on Keep Original. So now when I create my offset, you'll notice that the original is left alone and the new surface is generated. I'll undo that. I'm going to come back in, do another offset, and this time I'm going to do a variable. Select my surface, and you'll see I have a manipulator in the middle. It moves all of the corners, and I also have the ability to move a corner all by itself, singularly. So I can create these variable offsets. Now, if I come in here and turn on Keep Original once again and select OK, you'll notice again it creates a new surface. It also doesn't have history, so there's no history with this. And because of that, you're going to be able to use things like the match and control points to manipulate the surface as you see fit. There are several methods in which you can break, split, or trim elements in Catia. First, in generative shape design, we have split. With split, you have the ability to pick the element or elements you want to cut and the elements that are going to do the cutting. I'll pick the surface. You'll notice that it splits that surface. It removes this portion. I can pick a curve. I can also pick a plane. So the split is allowing me to pick any element so long as it splits the element to cut. If I want to keep the other side, I can specify the other side. Just make sure I have the element specified correctly here in the menu. So if I go up to curve 1 and say other side, you'll see it switches it over to the other side of curve 1. So if you have a very long list of things in here, it may be a little tricky. So just go careful, and the system is really good about indicating what it is you're highlighting. So here I pick the surface, it highlights that surface. If I go back to the curve, it highlights that curve. So it shows you exactly what the element is. So you can go back and make whatever modifications you need to make. And as you can see, I have a split in the tree because it's generative shape. It has history. I'm just going to undo that. Now under split, we'll go to the little black arrow here and we'll go into trim. Trim is a little different in that you need to pick similar type of elements. I can pick 2 curves, 3 curves, 4 curves, or I can pick 2, 3, 4, 10, however many I want, surfaces. Surface number 1 and surface number 2. As you can see, it splits away the material on the opposite side, or the side away from that I picked, and it wants to join those 2 elements together into a singular element. And that's why with trim, you have to pick similar element types, because at the end of the function, it's going to join those. So if you're trying to pick a curve in a surface, it won't allow that because it cannot join a curve in a surface. I'll undo that. And the third tool I want to use is in Freestyle. With Freestyle, it's called break, surface, or curve. You specify the type of element you want to break, curve or a surface. In this case, I want to break this surface. And what's my limitation? The limitation is going to be this curve. I select apply, and similar to the GSD, it shows you what side is going to be kept. I can pick on the side that I want to keep. Because this is a freestyle, this is tolerant modeling, you may have a curve that has a bit of deviation to the surface, and it'll show you the deviation error based off of those inputs. So that's why you see those deviation errors there. You have several other options here. So if the curve doesn't actually sit on the surface, you can project it along the compass direction. You can do along a normal. You can also do a view direction if you want. You also have extrapolation. So if the curve doesn't run the entire length of the surface, you can have it extrapolate tangent or curvature. And down here, it gives you the deviation. You can turn on and off that deviation. if you want to visualize that. And then next is what's called trim type. You have a couple of different kinds of trims. One of them will trim the surface and leave the control points as they were. And you also have surface trim, which will recompile the control points. Basically, it'll take this, remove this portion, and that surface is now trimmed back to this edge. There's no history or anything beyond that boundary. It recompiles those control points. So this may cause your surface to change shape drastically if you don't have enough math, if the orders aren't high enough to fulfill those requirements. So when you're using break, there's a few things you have to be very cautious with, but when you're done, it creates a nice clean trim, and as you can see, it actually breaks said surface. It doesn't create another feature in the tree for you, so there's no history to that break. But you just have to be a little careful, make sure you get what you want. And you can always go back and undo things and retry the break if necessary. In generative shape design, we have a tool called Join. Join allows us to pick all of the elements, again, these have to be similar type of elements, to join into making one singular feature. If I'm picking curves, it's got to be all curves. I'm picking surfaces, it's got to be all surfaces. If you're trying to make one final big surface that needs to be joined for manufacturing purposes, you want to make sure you have check manifold and check connexity on. This makes sure that the edges touch, they don't overlap, there aren't gaps, that type of thing. You also want to make sure that everything merges within a specified merging distance or modeling tolerances. And once you pick your elements, you hit preview and you get this little arrow. This arrow is indicating the final normal of the joined elements. And for this, if it's going in the right direction, you leave it alone, hit OK. If it's going in the incorrect direction, you just simply select on the arrow and hit preview once again. And just like that, the surface is going to join into one big element and the normal is pointing in the correct direction. This is important for downstream use if you have things built off of a join, or if you're going to take one surface and replace it for the next surface, you want to try and make sure that the normals align. And this is a really good way of taking several elements all at once, joining them, making them one, and then forcing the normal to go in the direction that you need. As you're going through and creating your surfaces through your reference data, whether it's a mesh data or curves, or whatever that may be, you want to go through and verify to make sure that the data that you create is within tolerance to your background data or your input data. And for that, we use a tool called distance analysis. Specify the surface, specify the mesh, or this could be curves or whatever, and it lays out a tolerance, maximum deviation tolerance. I have that turned on right over here. Show me the max values where the issues reside. And there are several display options here. You can turn on and off if you want to see a color range where the deviations are located at. Let me turn on the texture mapping so we can see that color range. And you can see it gives you a nice indication of how things are spread out across the surface, where the tightest areas are located at and the loosest areas are at. Turn off my texture mapping, turn off that gradient display. Discretization is how many samples it's measuring. So if I have a very large mesh, I may want more samples just to make sure that it's checking a lot more points along that surface. It may take a little more time for it to happen, to do the analysis, to perform it properly, but it also allows you to verify that you don't have any wild points or you don't have anything really crazy going on along that surface. Other things that I can do are turn on my combs, and you really don't see anything, so what I'm going to do is I'm just going to double the value, the length of the comb. And as you can see, I reach a certain point where you can really see those combs, and this is indicating to me basically the color map, but in 3D space. You can see where those deviations are occurring, and the combs represent a different deviation. The longer the comb, the greater the deviation. And you can run across those points and get an idea of how big or how small that deviation is back to the original surface. I'm going to select combs, turn that off. I'm going to leave everything as is. And I want to create the distance analysis. And this is nice now at this point. So if I were to go into something like control points and do a manipulation of the surface, I'll just come in here, right mouse click and go down to 3, right mouse click and go down to 3. You can see I'm now creating a larger deviation to the base reference. And because of that, I may need to come in here and do some manipulation of the surface to align it to get it to where I want it to go. So that's where the distance analysis is really handy. It allows me to visualize where my deviations are at. And again, those deviations might be necessary. You may have a poor quality scan, or maybe your curves have a lot of issues, and a larger amount of deviation may give you a smoother surface, but you may have to go back in there, tweak things to make sure you get the highlights flowing into the part or away from the part the way that the stylist wants. Next, there's a couple of visualization checks that we need to run through. One of them is called Connect Checker, and this is inside of Generative Shape Design as well. And this is doing a check of connection between edges on this surface, between those faces, those patches. I want to make sure that I have internal edge turned on. And with this, I just come through and I toggle the type of analysis I want. Right now, it's a G0 continuity. This is telling me that I have a 0.002 millimeter, very small. Some places this may be acceptable, and some places this may not be acceptable. So you have to make sure you know what your allowables are. And same thing with your G1. Here I have 0.077 degrees. So if this is below that, you can see I can tell where that little indiscretion is located at. And again, this may be well within your range. Some places have a G0 continuity of 0.01. Some places have a G1 continuity, maximum allowable of 1/4 of a degree. Some places have a 1/2 a degree. So again, it's up to where you're working or your OEM determining what those tolerances are at. So I can come over here and look for G2, and this could go all the way up to 10 in some places, 10%. And for G3, you can see everything in this case is going to be off. This is an interior part, and for the most part, interior components aren't going to really be concerned with a G3 type of continuity. Next is what's called highlight lines. Highlight lines, this is located only in Freestyle, and the way this works is you pick the surface you want to analyze, and based off of a vector direction, normal to that direction, pitch angle, it sets up these lines projected onto the surface. And this is a visual mapping of the shape of the surface using these curves. And as you can see, it comes across these boundaries, and you can get an indication of what's happening across these boundaries, visually speaking, to get a good look, close look at what's happening. Now, as I walk this across the surface, I don't see any sudden interruptions in shapes or changes. I see a little warble in here that somebody may not like. I may have to add a little bit more peak to that surface or flatten it out based off of styling requirements. But this allows you to, again, visually see what's going on with that surface. I can increase or decrease the pitch angle. So this is going to change how many of those highlight lines are walking across the surface. If I go up to my compass and right mouse click and change my privileged plane, it's going to project those lines normal to the surface based off of that, again, what would be the z-axis of the compass. I can also do a tangent, and again, this is going to analyze across those boundaries. And as you can see here, I got a tiny little squiggle based off of that view. Typically speaking, it's going to look good in 2 views. The third view may not be perfect, and for the most part, that's going to be acceptable for something like this, an interior part that's got a grain. If it looks good in other directions, then typically speaking, any of those small anomalies may not be an issue. But in this case, this may be something you want to go back and look at. Next tool I want to talk about is a tool called Extend. And what this is for is taking curves and surfaces and making them larger. So I'll select the surface, and it sets these nodes up on the four sides of the surface. What this does for me is it allows me to grab that node and drag the surface. You can see I can make it smaller as well and larger. And it keeps the shape of the surface as we make things bigger or smaller. I can do the same thing with curves. Now notice that this curve has no history. This is a NURBS curve that doesn't remember its parameterization. It knows that it has control points. It knows that it was constructed. It knows it has all that math, but it doesn't have the parameters of the points that initially were used to create it. So when I modify this curve, it allows it to modify simply without any issue. If I want to extend something, whether it's a curve or a surface that has history, in this case, like this 3D curve, this will happen with the surface as well. It's going to pop up with this information window saying, I can't extend this element, but I'm going to create a new element and the feature result cannot be modified. Basically, this means that it's not going to have history to anything. So if I modify the initial 3D curve, the new extended curve is not going to remember that. It's not going to have that history. So I'll select OK, drag this out, select OK again, and here's that 2D curve. So if I were to make a modification to this 3D curve, you can see that there's no historical link, no updates, no nothing back to it, because the new curve that's generated off of it basically copies it, takes that math, and makes it a non-parametric or unlinked copy. There are times where you have non-NURBS geometry and you want to convert it into something that can be used in the Freestyle workbench. Here we have a couple of extrude surfaces. If I go in and use a control points on one of these surfaces, I'm going to get this message. This is going to convert it into a NURBS element, something that it can use. I select OK, and at this point, I can begin manipulating that surface. Come in, we'll just say normals, move that off, and as you can see, it's generated that surface. The system automatically generated that surface for me. You'll notice that it has no history, nothing linked back to that extrusion. Now, in the middle of a workflow, control points, extend, several tools will do that for you automatically. But there are times where you want to control what's happening to that conversion. And for that, we use what's called a converter wizard. This converter wizard allows me to pick a surface or a curve and basically match the math that I want, or tolerance that I want, or segmentation that I want on that surface. If I just let a tool dictate what happens, it's going to potentially give me a very complex surface. This allows me to minimize that complexity. We'll go into more and auto apply. You can see that there's no real deviation. This is a fairly simple shape. If I need to, I can reduce the complexity. I can increase the tolerance, something that may pull away from the original surface a little bit, but I get a much simpler surface. So if you're bringing something in from generative shape design and you need to manipulate it with control points, this allows you to do that and simplify that math as you're doing it. As you're working with your curves and surfaces, you want to make sure that they look good. One great way to do that is to visualize the control points. Now, the control points that we use here for manipulating the surface can be displayed using a tool called Apply Dress Up. I can show control points and segmentation. I'll turn both of those on, select OK, and as we can see, I have my control points displayed in this blue frame. These dashed lines that you see are just isoparms across the surface. Go ahead and hide that. Now, I'm going to do the same thing with this corner surface here. Pick my corner surface, turn on the display, control point segmentation, and hit apply. Now this is a very complex surface, and I know this because as I visualize it, I have a lot of control points. I also have these solid font lines across the surface. These solid font lines are the segmentation, or they're invisible patches on the surface across those boundaries. So this is a very complex surface. If you're seeing a little bit too much, you can turn off that segmentation and hit apply. And now you just see the actual control points. If you just want to get rid of the control points and turn on segmentation, you can do the same as well. Once I have a dress up applied, you'll notice it doesn't put anything in the tree for me. So one way I can turn those off is just to pick the surface and turn off the apply dress up or remove dress up. So it's like a switch on and off. Let me go ahead and show this surface. So now if I go back in, I have those control points. If I click on the control point icon and look at those control points, you can see what ends up happening is they turn green, and these are now active for me to pull or push the surface as I see fit. I select OK, and that display now comes back and returns. So this is a really good way to verify that the surface you're looking at is nice and smooth and clean, because if you see any odd interruptions in that control point display, you'll know that there's something weird going on with the surface. To analyze the shape of a curve, as well as the continuities of a curve as they come to the endpoints of one another, I have a tool called Porcupine Curvature Analysis. Select my Porcupine Curvature Analysis, pick my curve, and it sets up these quills with this green envelope curve. Now, there's a couple of different types of analysis. There's radius and there's curvature. Let me go ahead and increase the length of the quill. One is the inverse of the other. So what's going to happen is if I'm measuring the radius is typically used for longer, broader, flatter curves. Maybe you're doing something across the hood of a car, something like that with big, long, broad strokes. Radius is really good to use for those types of curves. If you're using something with a lot tighter curvature, you may want to come in there and actually use a curvature graph like this to get a good indication of what's happening in the smaller, tighter areas. As you can see, I have a much larger exaggeration in the tighter radius. Now, again, back to continuities. The continuity is displayed by this envelope curve. As you can see, this envelope curve doesn't touch, but the quills at the ends are parallel, so that means they're tangent. And that's a great way to verify that the curve that you're looking at visually is tangent. I'm going to select OK. I'm going to double click on this styling fillet, and I'm just going to change this to G2. Select OK. Now you can see those quills have changed, and this is indicating at this point that this is a G2 or curvature continuity because that green envelope curve is now touching at those endpoints. So the porcupine analysis is a very powerful tool that allows you to visually see exactly what's happening with your continuities on your curves. So in this case, all I did was take an intersection curve through the part and then analyze that intersection curve. Or if I have two curves that I'm building that I'm going to eventually extrude out or sweep along something, I can use this tool and do the same thing, get the same type of analysis to make sure that the curves that I'm using are perfect before I even create surfaces off of them. Now we're going to go ahead and create the initial primary slabs for the top and bottom of this armrest. This is scan data that's been broken up. And normally when you get your scan data, it's going to be in one giant scan, but here we've broken it up for you so you can go in and more easily create the slabs that are necessary. So we want to make sure our slabs geometrical set is our in-work object, which it is, it's underlined. And I'm going to sight down the z-axis. Once I sight down the z-axis, you'll see the xy is my privilege plane. So when I draw anything, it's going to go right to that xy plane. And I'm going to create a planar patch. 2 diagonal points. You'll notice that I've created it much larger than the initial scan that I'm going to match up to. Once I have that, I'm going to create a distance analysis between this planar patch and my top scan data. You'll notice it's 540 millimeters away. Which is fine for now. Select OK. And at this point, I'm just going to copy this surface and paste another one in there, because I'm going to need 2 of these because I'm going to generate another slab for the bottom. So I may as well create both at the same time. With my distance analysis active, I go in and come to fit to geometry. What do I want to fit? I'm going to pick that first surface. That's the one with my distance analysis. My target is going to be the top. I can also pick this out of the screen if I want. And once I have those selected, I hit fit. You'll notice it takes that surface, resizes it to the boundary that is the size of that scan, and pushes it on to the scan. You'll also notice that I have a max deviation of less than 1/4 of a mil. So oftentimes we're looking to deviate no more than 1/4 of a mil, maybe 1/2 a mil in some cases. In some cases you have to deviate a lot further simply because of scan quality. If you have deep tool marks or things that shouldn't be there, wild points, then of course you're going to have to deviate a little bit more in order to get a smooth surface. Now I'm going to go to my NV and increase that. Just click on it once and I'm going to fit again. And this time you'll see it gets even a little bit closer, and this is going to be a nice smooth surface going through this scan data. Once I have that right to where I want, I'm going to select OK. I'm going to double click on that analysis. The source is going to be the unprojected surface, and the target is going to be the bottom. Select OK. And once again, you'll see I want to take surface 3. This is the one that I've just attached my distance analysis to. And I'm going to do the same thing. I'm going to fit to geometry, this to my target, which is this bottom, do my fit, and I have a fairly substantial deviation. And for that, I'm just going to increase the NU value. We'll go up to 6. And I'll take my NV value, right mouse click, go down to 2, and fit once again. And as you can see, I am less than 1/10 of a millimeter away from the scan. So this is really good. I'm going to select OK. And just like that, I have my top and bottom slabs.